to show how to set up the stoichiometry map on 4.22. So the first thing that we need to do is we need to balance this equation, and there should be an arrow right here. That was just a typo. So when I'm balancing, I write out the atoms that I have in my equation. So I have sodium and I have oxygen. I have 1 sodium on my reactant side. So remember, we have reactants yields products. So I have 1 sodium and I have 2 oxygens. On my product side, I have 2 sodiums and 1 oxygen. So I want to try to balance my my metal first. So I put a coefficient of 2 in front of my sodium, and then I distribute that. I then need to balance my oxygen, so I'm going to put a 2 in front of my sodium oxide and distribute that. So this 2 becomes a 4, this 1 becomes a 2, and now I just need to go back and balance my sodium. So I'm going to change this to a 4, and then I am balanced. All right, moving down here. Looking at all of these, looking at this map, it's filled out for the most part. The only thing that we need to fill in is we need to fill in our molar mass, and we need to fill in our stoichiometric ratios. So here, I need to fill in my molar mass for sodium. Okay, so my molar mass for sodium, I just look at my periodic table. One sodium atom weighs 22.99 grams. Next, to convert from moles of sodium to moles of O2, I need to put my stoichiometric ratios here. So I look up at my balanced equation. The coefficient in front of sodium is a 4. So I'm going to put a 4 right here. The coefficient in front of the oxygen, there's no coefficient there, so we can assume that it's a 1. So I'm just going to put a 1 there. Coming over here, our coefficient for sodium oxide is a 2. And again, our coefficient for oxygen is just a 1. Okay, then coming over here, we need to put the molar mass for sodium oxide. So 2 sodiums plus 1 oxygen weighs 61.98 grams.